Good afternoon, everyone. Literally, I suppose, different to a lot of the talks that have been given today, I'm very much coming at this from the vaccine end user. So I work with Teagasc, who is the National Agricultural Research Institute in Ireland. So essentially we work very closely with farmers to literally investigate control programs, disease control programs and eradication schemes at both farm and national level to see what's appropriate. So at present we are 2 years into a compulsory BVD eradication scheme in Ireland. So we are now looking forward to the surveillance phase of that eradication scheme. And it's very important for us, seeing as how we do not have a kind of a DVA strategy available to us for BVD, we need to see what are the best means of surveillance that we can use for looking at BVD into the future. So the title of my talk then is just Impact of BVD Vaccination on Bulk Milk P80 ELISA in Dairy Herds. So what is bovine viral diarrhea virus? It's actually probably one of the most endemic viruses of ruminants pretty much globally. It is present in, I would say, the majority of countries globally, besides some EU countries that have decided to eradicate it. Some countries, it is possible to successfully eradicate. Literally what you're trying to do is find these persistently infected individuals inside in a herd. These are essentially immunotolerant to BVD virus. They become infected in utero, become immunotolerant to the virus, are literally born as little virus shedding factories, and they will live throughout their lives shedding BVD virus 24/7 and infecting herd mates and producing more persistently infected individuals. So it is associated with a number of clinical signs. One of the main losses would be producing these very poor, ill-thrifty calves. Now, that is probably one of the most obvious clinical signs you get to see, but it also causes abortion, which can be very costly in dairy systems that need to produce a calf on an annual basis. There are also a lot of subclinical effects. So there have been reports on reduced milk production and general overall farm productivity, especially on dairy farms. There's also a cost, of course, to animal welfare. Any disease that's just left run endemically throughout a herd or a national herd is going to have impact on animal welfare. So there are quite a number of countries have impacted on national eradication schemes in Europe. Mostly the Scandinavian countries are those that have managed to eradicate it. But like I said, Ireland's probably jumping on the bandwagon a little bit late. But having said that, we're able to use strategies that others have tried and failed. So it's working out quite well for us. If you want to control and eradicate BVD, essentially what you have to do is identify these persistently infected individuals. They're very easy to detect. The diagnostics we've available for them are excellent. There's both antigen and antibody ELISAs available, which are highly efficient. So you identify these persistently infected immunotolerant animals, basically cull them out of the system, job done. The problem is you need to identify all of these PI animals at the same time, remove them all at the same time, and then you achieve eradication. But it has worked. It's worked very effectively in Switzerland in the past 3 years. They've essentially gone from having 1 to 2% prevalence of these PIs in their country down to, we'll take it as nothing at the moment. They're essentially considered free, and that's in the space of 2.5 to 3 years of an eradication scheme. So really is a lot of potential. So again, you remove these persistently infected animals. You obviously have to have biosecurity to make sure you just don't buy it back in again, which is a big problem with animal disease. And then vaccination does have a role to play. Now, because these PI animals shed so much virus on a daily basis, the vaccines we have available to us, they are not the main control mechanism for BVD. Your main control mechanism is the removal of PIs, but vaccination is an adjunct, shall we call it, not therapy, but it's an additional measure that we can employ on farm to actually assist in control programs. And that's especially true in areas where we'd have very, very high seroprevalence and a lot of viral circulation on farm. So the biggest problem, I suppose, that we have and that the Swiss have at the moment is we're mid-eradication scheme. Swiss have just finished an eradication scheme, but you obviously need to keep post-eradication surveillance going. And in the main, post-eradication surveillance is going to be, it's dependent on antibody detection. So just serological detection. And that can either be in serum or what's very, very commonly used now is actually using milk samples. So for dairy herds, you can actually take a bulk milk sample, check it for anti-BVD antibodies, and you will know whether your herd has been exposed or not, or whether your herd contains animals that have been exposed to BVD virus. There is one slight problem with that, is that because BVD virus can circulate within a herd from these PI'd animals for a long, long time, and anti-BVD antibodies can persist easily for up to 3 years in an animal that has been naturally exposed. A lot of the time, if you get a bulk milk positive result, you're dealing with possibly a historical infection. So it is not automatically massively informative. By getting a high bulk milk reading back as a farmer, that means I could have had BVD last week, 2 years ago, 3 years ago, or even longer. So again, very, very useful to use bulk milks for surveillance in countries, we'll say, that have already eradicated the disease and have very, very low seroprevalence. But what you can do in countries that have a higher seroprevalence is you also do what we call spot testing. So what you do is doing serology of unvaccinated young stock. So in the main, Irish herds are spring calving dairy herds. So you will get calves born in the spring. In October, once maternal derived antibody has waned, that any passive antibody has removed out of their system, it's been statistically shown you can literally sample 5 of these unvaccinated young stock. If they show up antibody positive, if at least one of those shows up antibody positive, it is likely you have had recent recent BVD circulation on the farm. And the main reason being they've only been on the farm from a maximum of maybe 6 to 9 months. So if they're antibody positive, they have to have picked up the virus recently. So spot testing combined with bulk milk are very, very useful as a surveillance strategy. Then we have the other problem. We have to be very careful with spot testing that we are using unvaccinated young stock. But like I said, we have no DVA vaccination strategy for BVD. So there's no way of differentiating a vaccinated individual from an infected individual. What this led Scandinavian countries to do was they actually banned vaccination during eradication. So that at least if they found an antibody positive individual, that was an animal that was going to be taken out of the system, or at least was going to be indicative that viral circulation had occurred. The problem is we really need to keep vaccination as some sort of a control measure in very high seroprevalence countries that would have been in Switzerland and like we have in Ireland. So again, that really restricts the usefulness of bulk milk analysis as a surveillance tool. Now, there has been a theory published, and this has been going on for a good 20 years at this point in time, of various different groups investigating it, that you can literally take certain combinations of a P80 ELISA, an inactivated BVD vaccine, and that will allow interpretation of serological results without interference from vaccine-induced antibodies. And the theory behind this is a P80 protein is a non-structural protein made by BVD virus. Because it's non-structural, the assumption is made that this will only be made by a replicating virus. Therefore, an inactivated BVD vaccine should not produce or should not stimulate antibodies against P80. So if you're using a P80 specific ELISA inactivated BVD vaccine, again, it's possible that you could not have a DVA strategy, but something similar. Now, the biggest problem we had with that is there have been quite a number of equivocal results reported. A lot of this is due to different pharmaceutical companies sponsoring different projects and getting the results that might suit their particular product. So what we decided to do, literally just as an independent study, and because we really need to keep bulk milk surveillance as a tool in our eradication scheme and post-eradication scheme, we wanted to complete a large-scale farm-based study investigating the impact of inactivated BVD vaccines on bulk milk antibody analysis in a high seroprevalence region. We also wanted to take a look at seasonality in bulk milk readings. It's just for certain diseases there can be a seasonal effect if you're using milks, down to various dilution effects, and again just the period of the year that a virus may be circulating more commonly than other times. As a last thing, and I probably won't go into it, we just looked at some of the key influences on the different various vaccine brands that were used. So in terms of the sampling that we did, first off we had, what we did was we randomly selected 500 farms, and these were based on stratified proportional sampling. So again, we chose farms based on their geographical location and their herd size. And we ended up with 312 farms came back and volunteered to take part on a non-incentivised basis. Again, this, even though it looks like we've got a massive amount of herds down in the southern half of the country, this is actually very reflective of the dairy herd density in Ireland. So again, it's actually quite a good national representative. Most of our dairy herds are in the southern half of the country, with fewer in the northern half of the country. What we did with them, then we took a bulk milk sample from each of the 312 herds in March, June, August and November in 2009, and they were all subjected to a P80 blocking ELISA. What we also had to do was do an indirect total antibody ELISA just to ensure that farmers were administering the vaccine properly. This was not set up as a controlled trial, so we were not going out vaccinating the herds. We were simply going in as a retrospective analysis. So again, the indirect total antibody ELISA was used as a verification of vaccine administration. And again, we went in and we did the spot testing of 5 heifers on the farm. Again, they were home-born, unvaccinated, and they had to be over 270 days of age. And again, that was just to establish whether there was recent viral circulation on the farm. So that was the setup of the programme. We used the P80 blocking ELISA from Institut PregSure in France. Again, like I said, the diagnostic tools we have for both antibody and antigen for BVD are very good. Results are reported as % inhibition. The various information we had on each of our herds then, so we had the bulk milk test result, and that was literally just classified as positive versus negative. We had the location of the herd in the country, and this was based on whether they were in a high dairy density region or a low dairy density region. Enterprise type, whether they had dairy animals alone or whether they had additional livestock species on the farm. Herd size, and again, these would be the average herd size of a dairy herd in Ireland is 60 cows. So again, we have small, medium and large herds. Calving season, spring calving versus all year round, and over 85% of our herds in Ireland are spring calving. Again, we sent out a questionnaire to get their vaccination status and the vaccine brand that they were using. So we vaccinated versus unvaccinated. And the 3 vaccines that were licensed in Ireland at the time of the study were PregSure, that's made by Zoetis Animal Health, Bovalis, MSD Animal Health, and Bovidec, Novartis Animal Health. PregSure has since been taken off the market in 2010, and I'll go into why that is. Then we also had their spot test result, which allowed us to identify whether there was recent BVD viral circulation on the farm versus whether there was no evidence of having recent viral circulation. Then we went into a whole pile of stats. So essentially what we ended up with 8 different data sets of whether various combinations of whether they were unvaccinated, vaccinated, whether they had recent viral infection or no evidence of recent viral infection. We just assessed normality of the data using ladders of power histograms and stata. We had non-normally distributed data, so we used a Wilcoxon rank sum to examine the ELISA results across vaccine status and brand. What we also did, because we wanted to look at spot testing and bulk milk analysis, we did an ROC analysis. For those of you not familiar with that, you can set up what we call a classification variable and a reference variable, and you want to see how both of those represent each other, how well they represent each other. And I'll go through the results and explain that in a bit more detail. Then just multinomial logistic regression, and we also did generalised estimating equations to see was there any difference in seasonality across the different bulk milk readings. So what we did at the beginning was set up what were the criteria that we wanted a combination of the P80 ELISA and the vaccine to have if we figured that it would be useful ongoing in the surveillance programme. So, firstly, we don't want administration of the vaccine to give significantly increased levels of P80 antibodies. Now, some of this gets a bit more complicated, but essentially our median % inhibition value of unvaccinated herds that were not recently infected does not differentiate from vaccinated herds that were not recently infected. So again, we just want a flat antibody response. Again, similar to the DIVA type thing, we'd like to be able to distinguish vaccinated herds with those from those herds with evidence of recent viral circulation. So again, that the median % inhibition value of unvaccinated herds with recent infection is significantly higher than a vaccinated herds with no recent infection. And finally, we wanted to make sure that the vaccine was administered correctly and we got the total antibody response. So, the results that we ended up with, and to be honest, it was fairly clear-cut. We ended up with one vaccine and it followed the whole way through. So if we take this is our unvaccinated group over the 4 bulk milk times, and this is the median % inhibition, there was no significant difference between the Bovalis vaccine and the % inhibition values that we got in the unvaccinated herds. However, when we looked at PregSure and BVDv, both of those would have given us much significantly higher readings from administration of the vaccine. For the DIVA type strategy, what we wanted was that the vaccine would give us lower readings, that the vaccinated non-recently infected herd would give us lower readings than a recently infected unvaccinated herd, which again, Bovilis met that criteria. Again, these readings are significantly different from this group up here, but none of these are significantly different from each other. So again, we have no way of telling the difference between a herd vaccinated with PregSure, vaccinated with BVDv, and a herd that's actually infected. When we actually looked at all the vaccines inside in recently infected herds, there was no way of distinguishing any of them. So if there was recent viral circulation going on inside in the herd, it didn't matter what vaccine was in there or not, everything was going to give you similar results, and they're not statistically different. In terms of the indirect total antibody measurements, we would have found no difference between Bovilis and BVDv in terms of the total antibody response. There was a greater total antibody response than in unvaccinated herds, which we'd expect, and PregSure gave us these much elevated, more elevated readings. Now, I mentioned PregSure was taken off the market, and I think one of the reasons is probably down to these massive elevated readings. PregSure, it's never been conclusively proven, but there's plenty of evidence to back up the theory that PregSure was actually causing a new syndrome called neonatal pancytopenia in calves. So it was a bleeding disorder of calves. And it was discovered that these calves had only ingested colostrum from a cow that had been vaccinated with PregSure. So again, the antibody response, an indirect, and I'd say literally just the total antibody response being produced and the antibodies going into colostrum was just so sizable that it was causing a syndrome in calves that were ingesting this colostrum. But again, we would find that Bovilis, there was absolutely no difference. There was no statistical difference in the administration of BVDv and Bovilis. Again, these are just some of the figures to back it up. So we had Z values. Again, you'd have Bovilis versus unvaccinated, significantly different. PregSure versus unvaccinated were significantly different, but that meant that PregSure was actually higher than the unvaccinated as opposed to being lower, and BVDv gave us absolutely no difference. So again, it's just to put some of the figures behind the graphs. Now, the ROC analysis that I did, so like I said, what you have here is a reference variable and a classification variable. So the reference variable that we were using was the spot testing. So we had decided, had the farms evidence of recent viral infection on the farm. So we use that as our reference. And what we use as the classification variable is, could we use a different % inhibition cutoff point of the bulk milk reading to actually classify a herd as being recently having recent viral infection. And again, for the ROC analysis to work properly, we needed vaccinated herds to behave pretty similarly to the unvaccinated herds. The way to interpret these graphs is that straight line essentially represents an area under the curve value of 0.5. That means that there is absolutely no distinction. Your classification and reference variable, there's essentially no relationship between the two of them. One does not predict the other. The closer that your ROC analysis moves up here, which would give you an area under the curve of nearer to 1, the better your relationship is between your classification and your reference variable. So what we were looking for was herds vaccinated with any particular vaccine to give us a similar differentiation curve so that it was well able to distinguish recently infected herds from vaccinated herds. And again, we found that Bovilis gave us almost identical results to unvaccinated herds, in that the area under the curve, I think, was 0.78 for unvaccinated herds and was 0.77 for Bovilis, so it worked out quite well. PregSure and BVDv, on the other hand, gave us values. I think one of them is 0.49 and the other is 0.54. So again, were of no use whatsoever. The minute either PregSure or BVDv was introduced into the system, we could no longer distinguish or use any serology to identify farms that had recent viral infection. I won't go into influences in vaccination. We literally just did find some influences that certain type of dairy herds preferred using certain types of vaccines. Probably the most interesting thing we did show up is that BVDv and PregSure vaccinated herds again tended to have a higher likelihood of being bulk milk positive than a Bovilis infected herd. that can be interpreted two ways. You can interpret it that herds with really bad BVD decided to use PregSure and Bovidec because they thought they were better vaccines, or else that either PregSure and Bovidec did not work as well as Bovilis, and hence the herds were worse. So that's just something that needs further investigation. So again, our conclusions from this was Bovilis was the only inactivated vaccine that did not interfere with interpretation of bulk milk ELISA readings. Bovidec and PregSure both appear to elicit P80-specific antibody responses, which would limit their usefulness in surveillance programs. So essentially, we've now identified a method that we can continue with bulk milk surveillance, knowing that as long as our farmers vaccinate with Bovilis, we can actually properly and correctly interpret our bulk milk readings. So I'll take any questions and just acknowledgements or just co-authors. This will be published in the Veterinary Journal before the end of the year. It's been accepted for publication. And again, it's been funded by Irish Dairy Levy. So again, pretty much this work is funded by Irish farmers. Thank you.
Any questions? The farmers don't often use one brand 1 year, another brand?
No, they tend to be literally... They get their vaccines through the veterinarian most of the time, who the veterinarian tends to have loyalties to a particular company. But it was one of the limitations of the study. We only had their vaccine information from 2009 and we didn't have historical. But again, they tend to be pretty consistent in what they stay using.
Yeah. Good, thank you. Next speaker.